This is a transaction between peer. It's a single request answer message exchange. It uses the hop-to-hop identifier to tie the transactions together. So just a really simple one transaction there, and this is showing 2, 3, 4. They've also got delivered in different orders, which obviously the endpoint should handle. So the next one is the session. So for operator state is maintained between the client and the server. The client to initiate this, it must include the session AVP, as we said, which is an ID. But it's a string ID, it's not a number. So it has a formula how it's made up. And you can actually put in another AVP, which is equal to state maintained. And then the session ID is maintained throughout all these different transactions, which we've got some requests coming from here. So here's a CCR message, setting up some prepaid accounting, and then this is a termination. Okay. But they all maintain the same session ID throughout. Okay? Okay, session. So the ways of maintaining a session. So you can have a session timer AVP, which says this session will be maintained for this number of seconds until I terminate the session. Authorized lifetime, so max a number of seconds until user has to authenticate reauthorize. You can come in and the session lives for 20 minutes, but you have to re-authenticate with me every 10 minutes or whatever, etc. And there's also a grace period, which is a number of seconds after expiry of session lifetime before session is actually removed. So with this way, you can say this session is going to terminate, and you can set up a new on the same session to go back in. These are generalized AVPs, but with our different applications, they are used in particular ways with additional AVPs to actually run the service. So a session can be terminated by the STR, sent by the client. A vault session is sent by the server, or until the session lifetime expires, or in the case that a server client reboots, which changes the value of the original state ID AVP. So, other error AVPs which we have. So there is the concept of an error message AVP, which is quite useful. But obviously, if people reject stuff back to you, they do give you a diameter result code, but they can also put in there saying it buggered up because of this, which obviously, when you're all the way down the other end, it does help you to identify for both the supporting person and the person who's trying to be supported to say, I've got this error, I've got this message, what does it actually mean? So what we do from any of our stacks, we actually give back a decent error to say, this is why this has failed. I don't understand the AVPs, I can't route it, I can't route it for these reasons, etc. So for you support guys, hopefully a bit more easier to look at the PCAP and never actually have to trawl through the log file because it's telling you what the actual problem is. The error reporting host, so it identifies the node, if different from the original host node, who identified the error. So again, if you've got lots of hops, you can identify that this box decided to error back, etc. So you don't have to get traced all the way through the network to find where the problem actually was occurred at. Third AVP, another one, if you have an AVP which is unrecognized, it's got wrong content, shouldn't be there, should be there, you can have actually contained within the failed AVP what the missing AVP message information was. You also have the experimental result AVP, so where you have the result code, which is fixed in the base parameter, if you want to extend that, you can put that under your vendor-specific result AVP. And they can be the same, this is the dumber, they can be the same value as the other result code. So you can get back two different results back, and they can be the same value but mean different things. Okay, what messages are in the base protocol? Capability exchange. On the initial connection, exchange to validate connection. There's later slides on this to show this. The watchdog that we discussed, the watchdog timer. Disconnect peer, so I can request to say that I'm going to disconnect. And the reason why I'm going to disconnect, I'm either saying I'm going to disconnect because I'm going down, I'm shutting down, or I'm disconnecting because I don't like you, I never want you to connect again. So that is another way for the DPR to do. Abort session, or said about that, where a client initiates to stop a session in progress. Reauthorize, server indicates the subscriber is still using the service. So he's making a request to the client saying, are you still using this session, you're still using this because you've been quiet for a little while, you're still there. And then session termination, server initiated request to indicate termination of session. So those are the messages which are defined within RFC 6733. So here's the capabilities exchange. So the important information within this, you've got original realm, original host, accounting application IDs, so that's a list of accounting application IDs it supports, authentication application IDs it supports, and vendor-specific application IDs it supports, whether or not it supports inbound security as well. So we think we go back to, don't have to, I'm sure remember the nodes, we had a node which supported IDs of 0, 1, 2, 3, 4. They go in here accordingly. So when the server gets in the CER, it will go through its list of supported of these, and if it finds common, one or more common application support, it will respond back with a success and indicates the ones which are common. So again, if you think that's part of the discovery, so I can sit there and I know I've got these peers there, and I say, well, I support this, I support this, I support this, and you'll get back from the ones which they actually do support. So your routing will be based on the common applications, not on what you've necessarily got configured on the box. And it says, if no common application found, then the answer with diameter, no common applications. Okay, so that, to be fair, that is the connection message to get your peer finite state machine to in service. So they also have within the base a concept of election process. So sometimes, especially when you're connecting up DEAs, DRAs, you don't know whether you're the client end or the server, because there's no real concept of client and server, because you're not a true application client or a true application server. So they have this concept of, if you were both clients, and you're both connected into your listening sockets on the server side, when you did your CER exchange, you want to only have a winner, so you have this election concept. And the election process decides who wins by comparing the two original host IDs of the two messages in lexicographically order. So if you look here, his name will be client1.client.net, he'll be client1.server.net. We go along each one comparing who's the bigger. Of course, he comes through the S, so at the end of the day, server.net will be client.1. Okay? So he sends the CA back. He would disconnect his transport, because you can only have one transport layer, which is, again, so it can't just be a message exchange. These are on different transport layers. They're not on the same transport layer. So here's the watchdog. So the concept of the watchdog is just looking for inactivity messages on the link. So there's lots of messages being passed back and forwards. You don't send a watchdog because you know that you're getting messages from that end here. If you don't get an end, you have a period of time, a watchdog timer. If that expires, you'll send out a heartbeat, say, you there? He'll come back and say, yes, I am there. If he doesn't come back and says, I'm not there, you'll try again and say, sure? Do you want to be there? And then he'll come back, and there you go. So again, that's kind of the definition of how the base protocols come up with being able to do failovers and detect whether a transport layer is still there or not. Disconnect peer, again, you can disconnect any direction by sending a disconnect peer request and getting a response back. This is a bit of a grey area. I think it's because they just wanted a way to just tell you not to connect again. That's it. There's no other reason for this, because the other way to stop something is just to cut the transport. So if you want to disconnect, you just take the transport down, and then you got rid of them. Okay?